Good morning, AP Calculus, or good afternoon, depending on which section you're in. Today we're going to talk about the chain rule. So when I start these videos, please make sure you've got out all your notes and you're ready to go. As I go through them, I'll be doing a lot of examples, mostly focusing on examples, sample problems, and looking at different things. Don't have the opportunity to interact with you, so if you've got questions or if you miss something, you can go back and watch the videos again. They'll be posting on my YouTube channel, AZ Mathman. So you can go back and watch them, take notes. If you miss something in your notes, you can go back and look at them. Don't always have a lot of time in class to stop the videos and replay them. So we'll kind of go through and look at examples here. So today, chain rule. We've been through the quotient rule and the product rule, looking at a lot of different ways to do derivatives. Looked at some examples in some of the social sciences, and focusing in on how to take derivatives. Here's where it actually starts to get kind of hard. This is probably one of the more difficult lessons. Two-day lesson here, 4 parts, 4 videos for this as we go through into examples. So let's take a look at what it is, what it's used for, how we use it. So suppose I'm asked to take the derivative of something that's particularly difficult. So given y equals some function of x that is x squared plus 6x plus 1 to the 4th power. How would we do something like this? Your first thought might be, well, if I FOILed it out to the 4th power, if I FOILed it out 4 times, I'd have a nice, well-behaved polynomial, and I could do power rule and I could do it in my head. But that seems like a lot of extra work. I mean, what if this was to the 8th power or something ridiculous? There has to be a better way of dealing with these formulas. And there is. Whenever you get some crazy formula, there is always some sort of strategy, some sort of way of doing it. Now, in particular, the chain rule works for formulas that are a composition of functions. What do I mean by a composition of functions? Well, if I could write my f of x, my y, as some sort of f of g of x, or another way of thinking about it, if I could write it as f of g of x. As a matter of fact, when we think about this, here's the way I want you to think about it. I want you to think about the outside function and the inside function. And we'll talk in terms of what's the outside function and what's the inside function. If we go back up here and look at this, and if I decompose this, I could write this as the function x squared plus 6x plus 1 is my inside function. The outside function would be something to the 4th power. So the outside function is something to the 4th power. The inside function would be that quadratic. And if we can think about it like this, as the composition of functions, then there is a pattern to this, and we can actually take the derivative here. Now, at first, it's a little confusing what's going on and what happened here and what happened there. Slow it down, take a look at it. After we've done a few examples, though, it will get a lot easier. I promise you, it'll get a lot easier. Before we actually get into our first example, a couple of different ways I want to look at it. So if I've got some sort of y that is a composition f of g of x, I could let y equal f of, here's my outside function u, and my u equal g of x. There's my inside function, this function inside of that function. And then to do the derivative dy dx would be the derivative of the outside function times the derivative of the inside function. Now, this notation might be a little bit more awkward to look at, so here's a different way of thinking about it. Remember, if I've got a composition, I've got some sort of f of g of x, and if I want to find the derivative of that, that's going to be the derivative of the outside function with g of x still in it times the derivative of the inside function. I like using outside and inside. Another way of thinking about this is the derivative of the outside times the derivative of the inside. All right, so let's take a look at that example. Let me pull that example back up again that we were just talking about. Y equals x squared plus 6x plus 1 to the 4th power. Now, for the first lesson as I go through this, I'm going to break these down into the u's and the v's, to the two different functions, so we can take a closer look at them. Later we'll be able to do a lot of it, I think, quickly in our head. But right now I want to break it down. I want to think about this function, y, as some sort of function of u. And if I do, then this is u to the 4th. F of u is u to the 4th. That's a u there, u to the 4th. And I know that the derivative is 4u cubed. Now the inside bit, the u, is my g of x, which is the, I'm running out of room here. Let me get another piece of paper to continue it. The g of x is the x squared plus 6x plus 1. And the derivative of the inside bit, g prime of x, or the derivative of the inside bit, I can do this in my head, 2x plus 6. So I've got my outside function and its derivative, and my inside function and its derivative. If I put this all together using our formula from up here, think about it as f prime of g of x times g prime of x, my inside and my outside functions. Then this is going to become 4 times the inside function, which is x squared plus 6x plus 1, times the derivative of the outside function, which is 2x plus 6. There's my y prime. Now, you may or may not have caught it the first time through. And if you didn't, that's fine. But look at it overall. So I've got my outside function was u to the 4. Oh, what have I forgotten? I've forgotten the 3 up here, haven't I? That's to the 3rd power. 4 times u to the 3. 4 times u to the 3. The u is the inside function. I forgot the 3. So 4 times g of x to the 3rd, that's the derivative of u to the 4th, times the derivative of the inside bit. So I've got the inside and the outside. The chain rule says it's the derivative of the outside times the derivative of the inside. All right, let's take a look at some more examples. And really the best way to do this is to try to do as many examples as we can. The more examples, the better here. So let's take a look at another one. Suppose I've got y equals x plus 3 to the 4th power. All right, so my outside function y is, I want to think about it as a function of u. The outside function is something to the 4th power. And f prime of u, the derivative of that, would be 4 times that something to the 3rd power. Now the u, the inside bit, is the x plus 3. And the derivative, that's my g of x, the derivative of that would be, well, just 1. So putting it all together, I'm going to have 4u cubed times du. Now the u is the x plus 3, and the du is 1. And we can simplify this. This is 4 times x plus 3 cubed. Did you notice on that last one I didn't simplify? Right now I don't want to get hung up in all the simplifying and all the crazy algebra that can happen. I just want to focus on the pattern, on the chain rule pattern. All right, let's take a look at another example. I've got a bunch more examples for you here in today's lesson. This is all we're going to do, is just looking and doing a bunch of these. We talked about the trig, so it seems like a good time to introduce some trig here. Trig. Yeah, you know what? I'm probably still in the hospital when you're watching this video, and I can hear you groaning from there. Very, very frustrating, isn't it? Some of the trig. And as I've said before, there's not a lot of trig in calculus, and when we see it, we're just looking at the patterns and what to do. And for here, again, I want to break it down. What's my outside function? What's my inside function? Think about y as a function of u, and my outside function here is going to be the cosine. My inside function u, g of x, is going to be x squared. So the derivative of the outside function, the derivative of cosine is negative sine, and the derivative of the inside function is 2x. So putting this all together, I'm going to have the outside negative sine of u times du. Now my u is x squared times the derivative is 2x. And I could clean this up here a little bit and say negative 2x the sine of x squared. And there's my derivative. That's my y prime. The derivative of the outside times the derivative of the inside. All right, another example. And if you're missing these or want to go back and look at them, slow them down. Remember, you can go onto the YouTube channel and watch them. Suppose I have y equals the square root of 1 plus 1 over x. So a little bit annoying here. So take a look at it. What's the outside function? What's the inside function? Y equals f of u. My outside function is really the square root. I'm going to write that as u to the 1/2. It's really the square root is the outside function. And I know the derivative of the outside function is 1/2 u to the negative 1/2. My u, my inside function, is 1 plus 1 over x. So my derivative of that, my du, my u prime, or my g prime of x, however you want to think about it, would be, what's the derivative of 1? Nothing. What's the derivative of 1 over x? We'll think about this as x to the negative first power. So it would be negative x to the negative 2. All right, so putting it all together now, I'm going to have the derivative of the outside function, 1/2 of u to the negative 1/2. And what is the u? The inside function is 1 plus 1 over x times the derivative, times negative x to the negative 2. I can simplify this here a little bit. Let's see what's going on here. This is going to be in the denominator, so is that, so is this. I'm going to have a negative 1 over, and I'm going to have a 2 and an x squared, and I'm going to have the square root of 1 plus 1 over x. And I'm not worried about rationalizing the denominator or doing anything further than that. All right, a couple more examples. I know I'm moving fast. We've got a lot of time to work on this. So my next example, suppose y is equal to the cosine cubed of x squared. Now this one, there's a lot more going on in this one. Take a look at this one for a moment. And let's break it down. What's my outside function? Y equals f of u. The outside function is really, I've got something to the third power. Remember, cosine cubed, I could put parentheses around this, the whole thing to the third power. So u cubed. And I know the derivative of the outside function is 3u squared. But the inside function of that, my u, and I'm going to call this a g of v, we'll see why here in a moment, is the cosine of v. And I know the derivative of cosine is negative sine of v. But I've got another inside function. I've got a function inside a function inside of a function. That's x squared. So I'm going to call the v is some other function, h of x, which is my x squared. And the derivative is 2x. So take a closer look here. The x squared is inside of the cosine, and the cosine is inside of something to the third power. I've got a chain inside of a chain. So when we do the derivative of this, I'm going to put all of this together. I'm going to have 3 times u squared. Well, what's u? It's this. And the derivative is this. So putting it all together, I'm going to have 3 times my u squared. And what is the u? It's going to be the cosine squared of x squared, times the derivative, which is going to be negative sine x squared, times 2x. Oh gosh, let's clean this up here a little bit. So negative 2 and 3 is going to give me negative 6x cosine squared x squared sine x squared. That's a tough one. A function inside of another function. So negative 6x cosine squared x squared sine x squared. All right, another one. How about if I just have f of x equals the sine squared of x? A little bit easier. Kind of wish I'd done this one before that last one. That last one was kind of tough. All right, so can you tell me what the outside function is? F of u is going to equal, what is the outside function here? Something squared. And of course, the derivative of the outside function is 2 times the function. The inside is the sine of x. So the derivative of the inside, or the derivative of sine, is cosine. So putting it all together, I'm going to have 2 times my u, my inside bit, which is the sine of x, times the cosine of x. So 2 sine x cosine x, and does that look familiar? How many of you had pre-calc last semester? We should realize that this is actually a double angle formula. 2 sine x cosine x is really sine 2x. But if you didn't remember that, that's okay. That was a kind of a tough one. Might be helpful, though, later on. Sometimes you look at something and you remember it's a formula, even if you don't remember what it was. You know that there's a formula for it, so you can go back and look it up. All right, one more, and then we'll take a break. Y equals the sine of 2x times the cosine of 3x. Now, are we going to need to do double and half angle formulas here? No. But notice that we've got chains inside here, but we've also got this product going on. Sine of 2x times cosine of 3x. So we're going to be doing a chain and the product rule at the same time. All right, so if I think about it like this, y equals some function in u. That's going to be my sine of u. And the derivative of the outside bit of the sine is going to be the cosine of u. My u, think about it as a g of x, is going to be 2x, and the derivative is going to be 2. But notice I've got this cosine 3x over here as well. And I can think about this as f of v. Function of v is the cosine of v, and the derivative of cosine is negative sine of v, where the v is some other function. I don't want to use g of x again. I used f of x twice, didn't I? Oh dear. So g of x, that the inside bit is 3x, so the derivative is going to be 3. Oh boy, so we've got a lot of stuff going on. So I know I've got product rule, so the first times the derivative of the second plus the second times the derivative of the first, and I know I've got chains within each of those products. All right, so if we try to put it all together, my y prime is going to be the sine of x, the sine of 2x rather, times the first times the derivative of the second the derivative of cosine of 3x is going to be negative sine, or negative 3, I'm going to put the 3 in there, negative 3 of the sine of 3x, plus, so the first times the derivative of the second, plus the second cosine 3x times the derivative of the first. The derivative of the first is going to be, I'm going to put the 2 out front, cosine 2x. So let's see, can we simplify this? Can we do much with this? Y prime is going to equal negative 3 times sine 2x times the sine of 3x. If we were clever, we could probably combine those. Plus, bring that 2 out, 2 cosine 3x, cosine 2x. Gosh, there it is. And we're not going to mess around with the trig. We're not going to do anything there. We're just going to leave it like that. All right, so chain rule. It's difficult, frustrating, and if you don't get it yet, that's okay. We're going to do more examples, and we'll take a look at it, and I'm going to break it down, and we're going to do all of these little steps along the way, and we'll look at some more examples coming up. You might want to go straight on to the next lesson here. If you want to take a break and look over a couple of things, but I would recommend just going and playing the next video straight away. Talk to you in a minute.